think this might be
Alright, here we go.
Yeah.
It says, so what you want to do is pay attention to the language here. So the most important part of this question is understanding just the question. It says determine the area of the region bounded by the function and the x-axis on this interval. That is mathese for it's the integral from 0 to pi over 2 of the function 3 plus 4x plus cosine x dx. So that's a direct translation into math. What?
You still have your notes from yesterday?
It's online. I mean, it's on video.
Oh, it's on video?
Yeah.
Can I take a picture of it? Right there.
There's more. I don't know what it was. You can ask me later when I'm not recording.
I'll ask you later when you're not recording.
Alright. So when you integrate this, you get 3x plus 2x squared plus sine x. And take that from 0 to pi over 2.
Shouldn't it be minus sine x?
The
derivative of cosine?
It's not derivative.
I mean,
it's the integral. Integral of sine is negative cosine.
I agree with Mr. Schweitzer.
It goes the opposite direction of the derivative.
Right. So when I plug it in, I get, is that right? 3x? Alright. So I get 3 pi over 2 plus 2 times pi over 2 squared plus the sine of pi minus, if you plug in 0, everything is 0, right?
Yep.
3 times 0 is 0, 2 times 0 is 0, sine of 0 is 0.
What's sine of pi? What's sine of pi?
Sine of pi over 2 is 1. Sorry, thank you. So that's 1.
Wait.
But when you plug in 0, you get zeros. Go ahead. What did you want to say? Where are you?
No,
You look confused.
that's the trigonometry. Why did you not do, wait, you said something cancels out for sine pi over 2.
I didn't say that.
What did you say?
I said when I plug in 0, I get 0. For all 3 parts.
Oh, I agree.
Okay. So cleaning that up, 3 pi over 2 plus pi squared over 2 plus 1.
I agree.
So,
Can we put that all into one, or can we leave it that way?
Ask again?
Do we put it all into one, like, fraction, or do we leave it that way?
Either one's fine.
Okay.
Yes.
how did you simplify 2 pi over 2 squared into pi over 2 squared?
Squared both.
Alright. So the question is, how did 2 times pi halves squared equal pi squared over 2? Okay, that's the question. So first of all, you square that. So that's pi squared over 4. You agree with that?
Mm-hmm.
2 is the same thing as 2 over 1 times pi squared over 4. The 2 and the 4 reduce. So it's pi squared over 2. Okay? Alright. Now moving on to number 12. Okay? There's not enough space for number 12, so I'm doing it on separate paper. Number 12. I've got integral of x over square root of 3x minus 1 dx. So this looks like a u substitution problem. So that u equals 3x minus 1, du equals 3 dx. And I see there's still an x, and I don't have an x here. When you see that happen, what you want to do is solve this equation for x. So that's going to be u plus 1 over 3 equals x. Yes?
So I put that in both x's whenever I started to put it back in.
Okay.
Is that bad or good?
Well, it depends on what you end up simplifying to. So when I substitute this, well, first of all, let me solve this for dx.
1/3.
So you get 1/3 du equals dx. So now I do the substitution. So for the numerator, I get u plus 1 over 3. For the denominator, I just got square root of u. Did you end up with the square root of u in the denominator? Okay. And then the dx is 1/3 du.
Would it help us to make the square root an exponent of 1/2?
Yes. In fact,
Why
I'm gonna do
is
that
the square root of u?
What?
Oh, wait, never mind.
Alright, so now I am going to clean that up. So I have a 3 here and a 3 here. And really, these two 3's are at the same level of denominator. They're the same level of denominator, so I'm going to bring that out as 1/9 u plus 1 over u to the half du.
So if I already have 1/3 out, can I just do, like, is there any way to get this problem right if I already have 1/3 out?
We get the same denominators all the same.
So just bring out the other 1/3? And then
Order
multiply?
doesn't matter.
Alright.
Alright, now I'm going to clean up the algebra, right? U over u to the half is u to the half, and 1 over u to the half is u to the negative half. I divided each one by u to the half. Now to integrate, that's u to the 3/2 over 3/2 plus u to the half over half.
I don't think you're
It's
supposed
not
to
even a
integrate.
methodology, it's just.
Say what?
You're not supposed to integrate.
I'm not supposed to integrate?
The answers aren't integrated.
Ah, thank you. Good call. Alright, so he pointed out to me, number 13, it's not asking you to integrate.
12,
Alright, so actually you see,
section 12.
so here, right?
So taking it completely out like we did kind of messed us up.
No, it's right there. That's D.
I mean, here's what it'll prove.
Yeah.
Right? U to the half and square root of u are the same, so the answer is D.
Why are we getting 1/9?
But can we still say what you did once you integrated?
Yeah.
Yeah, I agree.
Why are we getting? Hey, Coach Switzer.
So there's a third here and a third here. That's where the 9th comes from.
So if there was u plus 1 over 4, is it 12? 1/12?
U plus 1 over 4.
Yeah, and the numerator, or the top part of that fraction. Because you're like, there's a third and a third. So you said let's make it 1/9. So if it was u plus 1 over 4, then would it be 1/12?
Okay, yeah.
Really?
No. If that's a 4, then yeah, 4 times 3 is 12, yeah. Alright, someone asked for me to continue. So let's clean that up some more. So that's 2/3 u to the 3/2 plus 2u to the half plus c. I'm going to distribute the 1/9. So that'd be 2/27. And the u is 3x minus 1 plus 2/9. And the u is 3x minus 1. So that's it.
That's it?
That's it. Ready for 13? Alright, 13.
Does 1.5 sound right?
For what? 13?
Yeah.
That seems kind of small. But I could be wrong. And there should be like a pi in there somewhere because of that semicircle.
But you don't go to that.
Oh, you don't? Good point. Okay, then yeah, that does sound right. Actually, it sounds too big. So you're going from 1 to -3, right? So you're looking for this area. So this 1 square is worth 1 unit, yeah?
Yep.
And then these 2 is worth another 1. And this one is worth a half.
But those are negative.
So those are negative, that's right. So that's -2 plus a half. You agree?
1.5.
So it's -1.5. Right? So it's -2 plus a half, which is -1.5.
All I have is my sign wrong.
Yeah.
Oh, so it's talking about the y-axis, not the x-axis? Or some of the x-axis, not the y-axis?
What?
When you're saying it's from 1 to -3?
Yeah. It's the x-axis, yeah.
Okay.
When I did a trapezoid for these,
Yeah.
is it bad if I did that as the height, then these as the bases?
No, that's how you're supposed to do it.
Alright, good.
Alright, number 14, it says to graph it first. There's no restriction on how you're supposed to graph it. It just looks like this. If you realize you're going from -5 to 5 and it's symmetrical around the origin, then the integral of 2x cubed from negative 5 to 5 is 0. If it's symmetrical around the origin, and you're going from negative 5 to 5, in other words, so negative a to positive a, they're just going to cancel each other out and get 0. Is the screen frozen? Okay, it just unfroze. Alright, that's it. But if you worked it out, you'll still work it out to 0, right? If you worked it out, if you go from negative 5 to 5 of 2x cubed, that's going to be 2x to the 4 over 4 from negative 5 to 5. That's 1/2. Let's take the 1/2 outside. 5 to the 4th is 625 minus 5, negative 5 to the 4th is 625 again. So 625 minus 625 is 0, so it's still 0.
I agree.
You said 25. Did you say 625?
I said 25.
Yeah, it should be
I did it
625.
differently, but I got the same answer.
That's because it's 0.
Because I took out a 2. I had 2x to the 4th
Yeah, I did too.
over 4, and then I took out a 2.
Yeah, but you got x squared, didn't you, instead of x to the 4th?
Yeah.
You did take the derivative, you didn't take the integral.
You still did a little
No, I added 1 and then divided by the new exponent.
3 plus 1 is
You got 3
4.
plus 1, you get 2.
You just did it a little differently.
Well,
If it works, it works.
it worked. It worked for that one.
So for like the trigonometry, like sine, cosine, what's the difference between the integrals of those and derivatives?
Opposite signs. Like the derivative of sine is cosine, right? But the integral of sine is negative cosine.
Okay.
The derivative of cosine is negative sine, but the integral of cosine is positive sine. Alright, number 15. So this one, here's how I suggest, because there's a way to, I can just give you a rule, or you can just set up the problem, right? So it says here, if a trapezoidal sum is an over approximation. So draw what would be the part of the trapezoid that would be part of the graph. What I mean by that is, let's say I have some graph. So I'm doing this, okay? And when I draw the trapezoid, you would draw it like this. So this is the basis of the trapezoid, and then this is that leg, right? This is that leg, okay? It might be a little hard to see here, but is this leg under the graph or over the graph? Under the graph. So if the leg is under the graph, it will be an under approximation, okay? So if I were to draw it like this, why is this pen? Oh, it's a dead pen. How often do you guys have pens die?
Very
Not a lot.
Especially
Yeah.
with this heat going on.
I actually normally lose them before they die.
Me too!
All this humidity.
Alright, so let's do this one. If I were to draw the leg of the trapezoid for this one, is that an over approximation or an under approximation?
That's over here, right?
That's an over, because it's over the graph. Except that's badly drawn, but
Yeah.
graph. But you can tell that it would still be above the graph. You agree?
Yeah, a little bit.
Alright, so this is an over approximation. So that's what I would do when I'm answering this question, right? Draw one trapezoid. So like from 1 to 2, draw one trapezoid. Is that going to be an over or under? That's an over. So this is an over, and if you draw this one, is that an under or over? Under. So this one's under, this one's over.
Can we just look at the graph?
Yeah.
Because like, if it goes like this, it's going to be an under. If it goes like that, it's going to be an over, right?
Okay. Okay. Blake just generalized, and let me tell you what he's just generalized. If it is concave up, the trapezoid is going to be an over approximation. If it's concave down, trapezoid is going to be an under approximation. That was his generalization, which is correct. Okay? Yeah. All right. Now, what about the right Riemann sum? So right Riemann sum, so I want to draw a right sum. So from 2 to 1, the right sum will be like this, right? So that's an under approximation. And over here, if I draw from 1 to 2, the right sum will be this one, which is an over approximation. And this example is looking for an under approximation.
This is 0.
Right?
So why did we do trapezoid for A and B and then right for C and D?
Because I didn't want to pull out as a graph.
But
Okay, so
I meant
we're looking for over approximation. So A is an over approximation and D is an over approximation, right? So it's A or D for the first part. And then we're looking for under approximations for Riemann sum. So which one will be the under approximation for Riemann sum? Huh?
C is under.
C and C. Is there any other that's an under approximation?
This B one?
If I drew a right, so if I drew a right interval from 3 to 2, it would be an over approximation.
Yeah, so
So A, right? If you draw here, it'd be underneath.
okay.
Can you draw a generalization about right Riemann sums and the graph of the function, like Blake did for trapezoid?
If it goes over is over, if it goes under is under.
Yep.
If it is a decreasing function, a right Riemann sum is an under approximation.
if it's increasing, it's over.
If it's increasing, it's
Wait,
over approximation.
Sure.
So the answer is A.
A is a what?
A is the answer to this question. Right? It's an over approximation for trapezoid, but an under approximation for right Riemann sum. So this question was taken from an AP test.
So how do you know that you need a over and an under?
It told you. Trapezoidal sum over approximation. Riemann sum under approximation. Alright, ready to go on? 16. The heart rate given in beats per minute for an individual, the AP calculus exam on my birthday is given by the graph. What is the best? Yep. What is the best approximation of the total number of beats the student's heart makes in the first hour of the exam?
I got 7,200.
Does that sound right?
Hold up.
Anybody do that problem?
Yeah.
Okay,
Happy
so let's
6
work it
days
out.
before your birthday.
What?
Happy 6 days before your birthday.
6 days.
It's March.
Made it up, Mark.
It is March. Oh, it's never mind.
Okay, I'm gonna find the area of this rectangle first. That's what, 1, 2, no, it's 2, 4, 6.
yeah,
That's 6 times 10,
Actually, no,
20.
you'd be right.
It's 60 times 60. So that's 3,600 down here. Is that correct?
Yes.
I did it different.
And then up here is,
400 for the triangle.
hold on, I'm gonna do trapezoids. So 10, no, it's 20, 40, that's 80, right? That's 80 high. So the height is 80. This is 10, 20, 30, and 60. So it's 40 times 90.
That's four.
So I'm getting 7,200.
Yeah. 3,600. Boom. That's 3,600.
Right, 3,600 there.
Yeah.
Add them and I get 7,200.
So your times is about 60 or something?
Oh yeah.
How did you get that, the 90?
You know that you multiply it by 60.
60 plus 30 is 90.
Yeah.
Right?
I did it
This is
differently.
60, this is 30, so that's 90. 40 comes from dividing 80 by 2.
Will they ever tell us a way that they want us to do it? Like using the trapezoid?
Yeah,
Formula.
on the free response.
So like how would that go? Like you have to use what they
If
say.
a trapezoidal sum. Oh, wait. I've given examples of AP tests where it says use a midpoint sum, use a right sum. It'll say right Riemann sum.
Okay.
Use a trapezoidal rule. It always, when they want you to do it, they'll tell you specifically. Alright, ready?
What's 30 times 80?
30 times 80? 2,400. 17 and 18.
I need help.
I'm not a psychiatrist. Okay, 17.
So the first thing I did was take it to where the square root wasn't in there. Like
The
I made
square root wasn't in there. What does that mean?
I brought it out to an exponent.
Oh, okay. Alright, so I'm going to let u equal x plus 5. So that means du equals dx, and u minus 5 equals x. Yeah? Everybody agree
So
with that?
what happens when the dx just like there's nothing with it? You just don't put it in?
I don't understand the question.
Like there's nothing, there's no x or number with dx.
I could put the x next to it if I want to. You can change the order of this.
No, I'm talking about du.
This one?
Yeah.
Then you just replace it.
But how do you replace something that doesn't have a value?
du and dx, they're equal to each other. So you replace dx with the du.
Because you change the variable, you gotta change the du.
Yeah.
And dx.
Alright, so I'm going to go from, so I'm replacing the x with u minus 5. I'm replacing the x plus 5 with u, so it's u to the half. I'm replacing the dx with du. The limits are different. The limits are different if, remember these are x values, so if x equals 5, what is u?
0.
10. Don't look at this one, don't look at this one, look at this one. Right, if x equals 5, 5 plus 5 is 10, so u is 10. If x equals 1, then u is 6.
Wait, what'd you do?
Okay, so when I have this integral over here, this is x equal 1 to x equals 5. When I come over to here, I have changed the variables from x to u. So it's no longer, whatever number's up here, I want it to be u values,
So
not
you
x
plug in
values.
5 into
Into this expression.
and then you plug in 1 into u.
Correct.
How come we haven't done that in the past?
Huh?
I said, how come we didn't do that earlier?
Because we didn't have limits earlier.
So you only have a limit when you have to bring out an x.
No, you have a limit when you have numbers. Though, when I say limits, these are the numbers I'm talking about. These are the limits.
That's like the interval, right?
These numbers up here are the limits.
Okay.
But it's in that interval, right? That's
Interval?
The same thing.
Interval? Yes, interval. I thought you said interval. Yeah. Okay, so now, clean that up algebraically. So that's 6 to 10, u to the 3 halves minus 5, u to the half du. Continue to integrate. So that's u to the 5 halves divided by 5 halves minus 5u to the 3 halves over 3 halves. Taking that from 0 to 10.
Wait, what?
6.
Why'd it go from 0 to
I'm sorry, 6. Thank you. I think I might have wrote 6, and then I can't read my own handwriting. I said 6, yeah. That's what I mean. Alright, anyways, so let's clean that up a little more. So it's 2/5, u to the 5 halves minus 2/3. Oops, that's not 2/3, it's 10/3, right? 10/3, u to the 3 halves, taking that from 10 to 6.
And then you go.
And then you go, I hope to God this is a calculator question.
Is it?
Well, don't you have to plug in like x plus 5? Or x plus 5 for you?
No. Okay, so the question is, do I have to go back to x values? I do not, because I have the u values, so I can just plug in those numbers. I do not have to go back to x plus 5. So I just plug in the 10.
What? Wait, how do you know what u equals?
It's right there, 10 and 6.
But,
Oh.
so, how do you know when you can do that?
When you've changed everything. Like here, okay, actually let me answer it this way. If you're asked to do an indefinite integral, indefinite means there's no numbers, there's no limits. If it's an indefinite integral, you have to go back to x. If it is a definite integral, and you have changed the limits, right? These were x equal 1, x equal 5, and you changed it to u equals 6 to u equals 10. If you've changed everything in terms of the u, you do not have to go back to x. Yes?
What if you keep the limits 5 and 1?
Then you have to go back. Then you have to go back.
Fair enough.
But if you change the limits, you can't go back to u.
So I'm guessing I just plug in.
You can't go back to x?
Yeah.
Yeah.
Well, you can't like substitute and stuff.
Right, yeah. That doesn't make sense.
So now,
Unless you change these numbers back. You can change these numbers back.
So now we're gonna plug in 10 and then plug in 6,
Yeah,
and
yeah.
then we're gonna subtract them.
We're already plugged in.
Right.
Now we just gotta do 6.
A t-shirt.
I know you can't read that. That says 2/5, 6 to the 5 halves, minus 10/3, 6 to the 2/3.
So you just plug in the 6.
2 to the 3 halves, sorry. Right, all I do is plug in the 10 and then plug in the 6 and subtract. And I'm gonna quit right there.
You're not gonna solve it?
No, I'm not.
Are you scared?
Yes, I'm scared. By the way, the AP test will probably stop here.
You don't think it's gonna be a calculator problem?
Right, I don't. I think they'll make you stop here. They'll say which one. Like you saw that one question, right? We just had a question just
So
like
it's gonna be multiple choice?
this kind of question. Yeah,
You talking about number 12?
yeah, yeah. Okay, hold on. I got too many creaking going on to hear you. Okay, you know how I got u to the half here? Add 1 to the exponent, divide by the new exponent. 1/2 plus 1 is 3/2. Right? It's just power rule. Alright, ready for 18? 18 is the same kind of problem. Ready?
So, when is it that you want to graph a definite interval?
Okay, so I'm going to clear that up right now. When you are taking the AP test, if you should graph it, the graph will already be provided for you.
Is that the same with your test?
Yeah.
Okay.
Okay? So generally speaking, if I want you to do it by hand, I won't provide a graph. Right? Do it the regular way of analytically. So don't worry about, do I have to graph this or not have to graph it? Okay? Either be in the directions, like if I want you to graph it, wait, it's multiple choice. I'm not going to ask you to graph anything. If you want to graph it, you graph it. But generally speaking, you don't have to. Okay? Alright, if I want you to use the graph to find the integral, I will provide the graph. Does that answer your question? Alright. So the review is kind of like a little bit harder than the test in that respect because I don't provide the graph for you when I tell you to graph it.
Did you get x equals u minus 3?
Yeah.
Whoa. Mr. Schweitzer. Wait. Why don't you just associate? Because there's a 2/3.
What are you talking about?
You can't just like times 2x times x times 2x times 3. What the? Because there's 2/3. That'd be so much easier if you could.
Yeah, I agree. So those are my values. So it would be 2 times u minus 3 and u to the 2/3 du.
Now we integrate.
I want to change my limits. So 1 becomes 4 and 4 becomes 7.
How do you know?
Because 1 plus 3 is 4 and 4 plus 3 is 7. I'm still going to do some algebra to this. I'm going to take the 2 out and multiply those two. So the u to the 5/3 minus 3u to the 2/3 du. Right? So that's 2 u to the 8/3. Is that right?
Yep.
Divided by 8/3 minus 3u to the 5/3 divided by 5/3, taken from 4 to 7.
Go ahead and make that 3/8.
So that's going to be, and that's times 2. That whole thing is times 2. You want me to distribute the 2? So if I distribute the 2, that's going to be 3/4 u to the 8/3 minus what? 2/10? That'll be 3/5. That's 9/5. So it's 18/5 u to the 5/3 taken from 4 to 7.
Why don't we put a C?
Definite integrals, we don't have C's.
Okay.
It's weird because last year I was like,
Because we end up doing top minus the bottom and the C is canceled.
And this year,
Wait.
nothing reading pages.
So when you do that, you get negative 6/5 u to the 5/3.
Negative
I took-
6
I touched it
fifths.
with my hips because I was going to switch it.
So that means it'd be negative
Where are you
12
getting negative
seconds.
6
Touch
fifths?
and started dribbling down
When
the
you bring up
It was
the
like nothing
5
but
there to go on the bottom.
That'd be
side.
9
Body
fifths.
off.
You multiply 3
I've
times
just
3.
been
You don't have
dribbling
that.
people like in the box. Like I don't.
Yeah.
Alright,
I'm so confident.
so that's 3/4,
I used to get scared, and now I just don't.
7 to the 8
I have so much
thirds,
confidence. It's coming back.
minus 18
Yeah,
fifths,
that's
7 to the 5 thirds,
That's all you get.
all that minus 3/4, 4 to the 8
I just need to be more
thirds,
careful. So,
minus 18 fifths, 4 to the 5 thirds.
I've
So on the
been
AP
feeling-
exam, where do you think this will stop it?
Here.
Sweet.
Really?
Yeah.
Can you scoot it back down?
I like that.
Thank you.
This has been a good season. We've got some-
Because after that is trivial, right? It just, that's just annoying.
So
Yeah,
really gives
I
you
agree.
time. Or-
That's gonna be our first challenge. 'Cause I think
I'm stopping the recording.
Is it put it up?
the only team